Here we have a magnetic circular motion question. So an electron that has a kinetic energy of 7.5 times 10 to the negative 17 joules moves in a circular orbit perpendicular to a uniform magnetic field of magnitude 0.35 Tesla. For this electron, determine the radius of its orbit, its angular frequency and period of motion, and its speed. So we're given the kinetic energy and the magnetic field. And so what is the radius of the orbit, what is the angular frequency and period of motion, and what is the electron speed? So we know the radius of the trajectory is mass times the speed times charge times magnetic field. And we know the charge, the electron, we know the magnetic field, we know the mass, we just don't know the velocity. So we know the kinetic equation, velocity, kinetic equation, and so it's just half times mass times velocity squared. We're able to rearrange this equation to solve for velocity. So all we have to do is combine these two equations, and it gives us the radius is equal to the square root of 2 times kinetic energy times the mass divided by charge times magnetic field. So we get 2 times 7.5 times 10 to the negative 17 joules times 9.1 times 10 to the negative 31 kilograms, and times the charge times the magnetic field, and our radius is 2.1 times 10 to the negative 4 meters. And so what is the angular frequency and period of motion? So we know the angular frequency equation, which is charge times magnetic field divided by the mass. So we know everything. All we have to do is plug in our answers. So we do 6.2 times 10 to the 10th power a second, which is our angular frequency, and our period of motion is 2 pi divided by angular frequency. And so we just solve for angular frequency, and so our answer is 1.0 times 10 to the negative 10 seconds to travel the circular path. And so what is the electron speed? And so we have the velocity at 2 times the kinetic energy divided by mass, also in the square root. And so all we have to do is plug in what we know, and our speed is 1.3 times 10 to the 7th meter a second.